In the past 200 years, humanity has made extraordinary leaps forward. We've transitioned from the simplicity of candles to harnessing solar energy, evolved from horse-drawn carts to advanced airplanes, and moved from basic sustenance to a diverse array of foods. Our understanding has expanded from a flat Earth to the discovery of space telescopes orbiting our universe. Today, we feed a global population of 8 billion with a level of food quality and quantity that would have been unimaginable to just 1 billion people 2 centuries ago. Slavery is now a part of history, and we've developed automated teller machines and robots that handle complex tasks. So, what has driven this remarkable progress? If we had to identify the key factors behind this transformation, what would they be? In this video, we'll explore the 4 foundational pillars of modern civilization that have propelled us to where we are today. Those 4 pillars of civilization are as: Number 1. Ammonia. Ammonia is an indispensable compound that plays a crucial role in feeding the global population. It serves as the primary nitrogen source in fertilizers, which are essential for modern agriculture. Without synthetic ammonia, it would be impossible to sustain nearly half of the world's population, which now approaches 8 billion. The Haber-Bosch process, developed in the early 20th century, enabled the large-scale synthesis of ammonia from nitrogen and hydrogen, revolutionizing agriculture by significantly increasing crop yields. This innovation has supported the dietary needs of billions, making ammonia arguably the most vital material for human survival. Approximately 80% of the world's ammonia production is used in fertilizers, which are crucial for the growth of crops like wheat and rice, particularly in densely populated regions such as Asia. The importance of ammonia extends beyond fertilizers. It is also used in the production of nitric acid, explosives, and various other industrial applications. However, the environmental impact of nitrogen fertilizers and their inefficiency in application present challenges. Despite these concerns, the dependence on synthetic ammonia remains high, especially in regions with rapidly growing populations like Africa, where increased ammonia use is seen as key to improving food security. Number 2. Plastic. Plastics have become an integral part of modern civilization, offering unmatched versatility and utility across various industries. Their unique combination of lightweight properties and remarkable strength has led to their widespread adoption in applications ranging from heavy-duty construction materials to everyday consumer products. The dominance of thermoplastics, particularly low and high-density polyethylene, PE, polypropylene, PP, and polyvinyl chloride, PVC, has transformed industries such as automotive manufacturing, aerospace, and healthcare. For instance, PVC is now a critical component in over a quarter of all healthcare products, playing an indispensable role in hospitals with items like flexible tubes, catheters, and sterile packaging. The rapid advancements in plastic production since the early 20th century have allowed these materials to revolutionize how we build, travel, and even receive medical care, underscoring their fundamental role in shaping the contemporary world. However, this widespread use of plastics has not come without consequences. The global production of plastics has skyrocketed, growing from just 20,000 tons in 1925 to an astounding 370 million tons by 2019. This exponential increase in production has led to significant environmental concerns, particularly regarding plastic pollution in oceans, coastal waters, and beaches. Despite these issues, the value of plastics in critical sectors like healthcare and infrastructure remains undeniable. The challenge lies not in eliminating plastics but in managing their production, use, and disposal responsibly, ensuring that these versatile materials continue to benefit society without causing irreparable harm to the environment. Number 3. Steel. Steel is one of the most critical materials shaping modern civilization. It forms the backbone of countless structures, machines, and tools, from skyscrapers and bridges to vehicles and household appliances. Steel's physical properties, including its high tensile strength, hardness, and heat resistance, make it indispensable in construction, manufacturing, and transportation. There are over 3,500 varieties of steel, categorized into carbon steels, alloy steels, stainless steels, and tool steels, each tailored for specific applications based on their composition and physical characteristics. The production of steel is a highly energy-intensive process, involving the smelting of iron ore in blast furnaces and the refining of cast iron into steel. Despite the significant energy demands and associated greenhouse gas emissions, steel is also one of the most recyclable materials. Nearly all steel products can be melted down and reused in electric arc furnaces, making recycling an essential part of the steel industry. This process contributes to sustainability efforts, with recycled steel accounting for almost 30% of global steel production. In essence, steel is not just a material but a cornerstone of modern society, enabling everything from basic infrastructure to complex machinery, all while being part of a circular economy through extensive recycling practices. Number 4. Cement. Cement, the essential ingredient in concrete, is produced by heating ground limestone and other materials in large kilns to form clinker, which is then ground into a fine powder. This cement, mixed with aggregates and water, creates concrete, a material that is the backbone of modern civilization. Concrete, composed of 65 to 85% aggregates and 15 to 20% water, with the remainder being cement, is robust and durable, especially when reinforced with steel. Though ancient Romans used a mix of gypsum, quicklime, and volcanic sand for their impressive structures like the Pantheon, modern cement was patented in 1824 by Joseph Aspdin. He created Portland cement, a material excellent in compression, capable of withstanding immense pressures but weak in tension. The development of steel reinforcement, starting in the 19th century, revolutionized the use of concrete, enabling the construction of skyscrapers, bridges, and vast infrastructures worldwide. Today, reinforced concrete is ubiquitous in urban environments, from skyscrapers and roads to dams and tunnels. The 20th century saw a surge in cement production, with China emerging as the leading producer, especially during its modernization drive. However, concrete is not a highly durable material and is susceptible to environmental damage, which leads to deterioration over time. The 21st century will face unprecedented challenges in dealing with decaying concrete structures, particularly in countries like China, where rapid urbanization has led to massive concretization. While affluent nations focus on repairing aging infrastructure, developing countries still rely on concrete for essential structures, such as replacing mud floors to improve hygiene. As concrete continues to dominate, the world will also witness an increase in abandoned concrete ruins, a testament to the material's widespread yet finite utility.
Thank you for watching and joining us on this journey through the 4 pillars of civilization. Your support and interest in understanding the foundations of our modern world are truly appreciated. Stay curious and keep exploring.